Rules and exceptions for finding the oxidation number. In a neutral compound, the sum of the oxidation numbers of the atoms should be equal to 0. For example, in water, hydrogen is showing a +1 oxidation state, oxygen is showing -2 oxidation state. There are 2 atoms of hydrogen. So each one is having +1 oxidation state. So 2 into +1 giving +2. And if we substitute that in water, H2O, on top of H2 we can write +2, and above oxygen we can put -2. So the sum of +2 and -2 will be equal to 0. So the total oxidation state, or the component atoms hydrogen and oxygen, when their oxidation states are added, it will become neutral, or it will show 0. 0 will be the sum of the oxidation states of the component atoms in a molecule, in a neutral compound. An element in its free state has an oxidation number 0. Example, in hydrogen, oxygen, sodium, manganese, etc. If they are not in a combined state, in their uncombined free state, they will be having 0 oxidation number or oxidation state. The oxidation number of an ion or radical means there will be 1 or 2 elements, is equal to the charge on it. For example, if it is Mg2+, it is a magnesium ion. Oxidation number is +2. That is the charge on it, on the ion. Cl-, oxidation number is -1. O2-, oxidation number is -2. But if it is a radical like sulfate, SO4 2-, oxidation number is -2. That is assigned to the whole, that group of S and O4. It is 2-. 2- will be the oxidation state, or -2 will be the oxidation state. Now group 1 elements, those are the alkali metals. They have +1 oxidation state in their compounds, like sodium, potassium, etc. And in group 2 elements, those are the alkaline earths, they have +2 oxidation state in their compounds, that is magnesium, calcium, etc. Next is aluminium. In group 3A or 13, it has +3 oxidation state. Hydrogen with non-metals will show +1 oxidation state. Example, in HCl, NH3, H2O, etc. we can take the oxidation state of hydrogen as +1. Hydrogen with metals and boron will show -1 oxidation state, like metal hydrides, sodium hydride, boron hydride. Boron is another BH3. Here all hydrogen will show -1 oxidation state. Oxygen shows -2 oxidation state usually. But there are a few exceptions, like in the case of hydrogen with metals and boron, it will show -1 oxidation state. Normally it shows +1 oxidation state, hydrogen. In the case of oxygen usually shows -2 oxidation state. But with fluorine, in OF2, it shows +2 oxidation state, because fluorine is more electronegative than oxygen. So the more electronegative atom is assigned a minus oxidation state. So with fluorine in OF2, it shows +2 oxidation state. In peroxides like sodium peroxide, hydrogen peroxide, etc., it shows -1 oxidation state. You know, in peroxides the bonding is different. Oxygen bonding is there. In superoxide like potassium, KO2, oxygen shows -1/2 oxidation state. It's a fractional oxidation state. So these are some exceptions while we are calculating, or while we are trying to find the oxidation numbers. In group 17, halogens like fluorine, chlorine, bromine, iodine, etc., they will be showing -1 oxidation state in their compounds. Whereas in their diatomic stage, that is Cl2, Br2, etc., they will be showing 0 oxidation state. But here, when they are combining with other atoms, they will show -1 oxidation state. Electronegative elements, these are. Then group 16, that is oxygen, sulfur, etc., they show -2 oxidation state usually, but the tendency to show -2 oxidation state decreases down the group. As you come to heavier chalcogens, this group is called chalcogens. That is the group 16. Now group 15A, nitrogen, phosphorus, etc., show -3 oxidation state. They also show +3, +5 oxidation states also, but usually it is -3. There also the tendency to show -3 oxidation state decreases down the group.